Packet forwarding. In this video, I'm going to talk about packet forwarding, specifically layer 2 forwarding again. You know that in previous video, we have learned about some fundamental topics related to the, for example, packet forwarding. For example, we have learned about the collision domain, about the CSMA CD, and also we have learned about the Ethernet in bus topology and also in the star topology. You know that now we are using switch because each port of switch is one collision domain and it is so useful. Okay, but you know that all of the interfaces, all of the ports in one switch by default are residing in one broadcast domain. When you want to segment the broadcast domains of network, okay, into multiple broadcast domains, one of the solutions is using the virtual LAN, or other solution is using physical LANs. Okay, in most cases we are using physical LANs, but because I want to review everything from the scratch, let me first introduce the creating physical LANs and its benefits and also its disadvantage. Look at here. Assume that we have one network. In this network, we have switch 1 connected to computer 1, computer 2, computer 3, and also we have switch 2 connected to computer 4, computer 5, and computer 6. Okay, when you have this network and when you are connecting two switches directly to each other without using the router, actually assume that here we have one link between the switch 1 and switch 2 without the router, you will have only one broadcast domain. What does it mean? It means that when the computer 1 is sending broadcast, this broadcast can reach to other systems, other hosts. And you know that because we are using broadcast in many features, each broadcast should reach to all of the systems, should increase the CPU usage, increase the bandwidth usage, and actually the resource usage. Okay, because of that, we need to segment this network to multiple broadcast domains, okay, or multiple LAN. Each broadcast domain is a LAN. The first and the easiest method is using routers. Actually, when you are using router, now this router is the boundary of our broadcast domains. What does it mean? Look at here. You know that each router has multiple interface. For example, here we have interface fast Ethernet 00. This interface is the fast Ethernet 00 in the router 1, and this interface is the fast Ethernet 01. Okay, but the router doesn't forward the broadcast from one of its interface to other interface. Assume that here we are sending broadcast from the computer 1. This is the broadcast for any reason. For example, we want to use the ARP protocol or address resolution protocol for learning about the MAC address or for finding the MAC address of destination. Okay, we should send broadcast message. Broadcast is sending to the quad F. Okay, this is the Ethernet broadcast frame. Okay, we are sending it. This frame is reaching to the switch 1, and switch should flood this broadcast, means should forward it to all of its interfaces. Okay, except the receiving traffic interface. Okay, actually here this broadcast can reach to the computer 2 and also computer 3 and also the router. Router doesn't forward this broadcast from fast Ethernet 00 to other interface fast Ethernet 01. Actually, here is the boundary of the broadcast. This is the first broadcast domain and this is the second broadcast domain. You can use the routers to create multiple broadcast domains or multiple LANs. It is useful, but let me to say that in real world, if you want to create multiple broadcast domains, okay, you need to use multiple routers or routers with multiple interface, and routers don't have, for example, many interface. Also, you will encounter with many problems. For example, assume that one of our employees, okay, is residing in this place and we cannot change the place or the position of this user to other room. Because of that, here now we have a problem because this user should connect, for example, to other switch. Actually, we will encounter with many geographical problems related to the position of the employees of our company. Also, assume that we have one router, one switch, and in this switch you want to create multiple broadcast. I mean, assume that we have a switch with 48 port, and we have in only this switch, okay, and we want to create multiple broadcast domains in this switch. By default, with router you cannot create multiple broadcast domain in one switch. Because of that, creating the physical LANs or physical broadcast domains with routers, okay, is not so useful in the real world. We need to create the broadcast domains logically, not physically, okay. Actually, in one switch we can create multiple logical smaller switch. We call them virtual LAN or VLAN. You have learned about the VLAN in the CCNA class, and now we are reviewing the concept of VLAN. After that, I want to configure again the VLANs. Look at here we have two physical LAN, not virtual LAN, okay. Now let me to show you how we can create multiple virtual LANs in one switch. All right, look at this picture. This is a switch. As you can see here, we have a switch, okay. As you can see, in this switch we have only one VLAN. Actually, all of the interfaces of this switch, like Fast Ethernet 01, Fast Ethernet 02, 03 to Fast Ethernet 02, 010 are members of the VLAN 1. Actually, they are members of one logical switch, and because of that, when PC1 or other PCs are sending traffic, broadcast traffic, this broadcast is flooded to all interfaces except the incoming interface. Look at here, this is the broadcast frame from the PC1. This broadcast frame now is reaching to this logical switch, and the traffic should be flooded to all other, for example, ports, as you have learned previously. And because of that, now we can understand that when we are using the show MAC address table in the switch, by default, you know that show MAC address table can show us the MAC address table of one switch. By default, actually we are using show MAC address table VLAN 1. This is the default VLAN that we have in all switches. Actually, when you are using one switch with default configuration, we have only one VLAN, and the number of this VLAN is VLAN 1. I will explain the different criteria about the VLANs, but because you have learned about these topics in the CCNA, I can use your knowledge. You know that by default we have VLAN 1, and all of these ports are members of the VLAN 1. Because of that, when we are sending broadcast, the broadcast is flooded to all of the other interfaces in the VLAN 1. And you know that we can use show MAC address table for viewing the MAC address table of one switch. With the show MAC address table, actually we can see the MAC address table of this virtual switch, okay. This virtual switch or this VLAN is VLAN 1. Because of that, show MAC address table VLAN 1, okay, exactly has the same result with the show MAC address table when you don't have any other VLAN, okay. Now let me to show you what is happening when we have multiple VLANs in one switch, when we can create multiple VLANs in one switch. Alright, as you can see here, we have again the same switch, but I have created multiple virtual LANs in this switch. It is so easy. You have learned about the creation of multiple VLANs, and I will configure it again for you in this video. But for now, let me to say that now here we have three VLANs, VLAN 1, VLAN 2, and VLAN 3. Okay, VLAN 1 has 4 members. Port 4, port 5, port 6, and port 7. VLAN 2 has 3 members, port 1, port 2, and port 3. And VLAN 3 has 3 members, port 8, port 9, and also port 10. Okay, as you can see now, actually in this physical switch we have 3 logical switch. Each of logical switch is calling the VLAN or virtual LAN. Okay, actually this is a virtual switch or virtual LAN. Okay, vSwitch, in some cases maybe you encounter with the term vSwitch, but in most cases we say VLAN or virtual LAN. Each virtual LAN has an identifier or VLAN ID, and it is a number VLAN 1, VLAN 2, and VLAN 3. Also, because now we have 3 VLANs, you can use show MAC address table and then the VLAN number for viewing the MAC address table of VLAN 1. For example, if you use show MAC address table VLAN 1, you can see that in this VLAN 1, about the port 4, port 5, port 6, and port 7, the MAC addresses that we have. For example, assume that we are using show MAC address table VLAN 1, okay? The first command